Okay, welcome to my office. Today I'm going to show you how to do some calculations for dilution series. We're going to be doing this in lab this week and in the subsequent weeks as well. So I wanted to outline how to do that, how to set up the formulas, and let's go through a couple of examples as well. So the very first thing we're going to be doing here is we're going to be using this particular formula is d1v1 equals d2v2. So this is the standard formula that we will be using for our dilution series. And in order to solve this equation, we have to know 3 of the 4 variables to be able to solve for the 4th. So let's get an example from your lab is using 0.1 milliliters of stock solution, and to that we are adding 9.9 milliliters of diluting fluid. And I'm just going to abbreviate diluting fluid so I don't have to write it out. So using this information from your lab, can we figure out what we need to be able to solve for here? And the answer is yes. When you see something that says a stock solution, unless you are told specifically otherwise, you should regard stock solutions as being undiluted. That means they're a 1-to-1. So in this case, we know our D1 is going to be a 1-to-1. Now we know our 0.1 milliliters is our volume 1. So we're going to put that here too. And now we don't know our D2. So we're going to be solving for that later, but we do know our V2. Now, what is our final volume going to be? Our final volume is going to be the volume of our stock solution plus the volume of our diluting fluid. So 0.1 milliliters plus 9.9 milliliters is 10 milliliters is our final volume for V2. So now in order to solve for this, we're going to solve for D2. We have to get it by itself on one side of the equation. And we're going to do that here by dividing both sides of this equation by 10 milliliters. When we do that, we're going to end up with our 10 milliliters over here. Now we've got D2 by itself, and we can simplify this a little bit. 1 over 1 times 0.1 is going to be 0.1. And we still have our 10 milliliters in the denominator, is our D2. These units will cancel, and now we can just finish doing the math. 0.1 divided by 10 is going to be 0.01 is our D2. Notice that D2 is a unitless quantity. There is no units, or are no units associated with this. So what we can say is if we were to take our 0.1 milliliter of stock solution and add 9.9 milliliters of diluting fluid, we would end up with a total volume of 10 milliliters of a 0.01 dilution. Another way of saying the 0.01 dilution is to list that as being in fractional form is also 1 over 100, if you wanted to list it that way as well. Okay, so that's one example. Let's try a different one, where we're going to be solving for a different quantity. Instead of D2, we're going to solve for something else instead. So the second example in your lab talks about what volume of a solution would be required to produce 250 milliliters of a 1-to-1000 dilution here, starting with the stock. So we know a few things here. We can figure out which 3 things we know. We know our final volume is going to be 250 milliliters. So we can kind of put this here. We know our dilution, first of all, is 1 over 1000. That's our D2. We know our final volume is 250 milliliters. And then do we know our D1 or our V1? And the answer is we know our D1 is a stock solution, so we know that that is 1 over 1. And it says we are trying to figure out what our original volume we need of our stock solution in order to make this here. So we need V1 by itself on one side of the equation. We do that by taking both sides of the equation and divide by 1 over 1. So when we do that, we end up with a 1 over 1 here, and that goes away. Now, anything here, numerator divided by 1 over 1 is the same as saying this quantity here, so we can actually just leave it this way. So our V1 is going to be 250 milliliters divided by 1,000 is the way that that is going to be set up. So 250 divided by 1,000 is going to be 0.25 milliliters of our stock solution is V1. Now we have to be really careful here because this hasn't told us how much diluting fluid we're going to need in order to get this final volume here to make it that dilution. So we know how much of our stock solution we need. We know that we're going to end up with 250, and we know that the final dilution is going to be a 1/1000, but how much diluting fluid do we need to add? Well, the amount of diluting fluid we need to add is going to be our final volume, 250 milliliters, minus our V1, so minus 0.25 milliliters here is going to be 249.75 milliliters. So we're going to need 249.75 milliliters of diluting fluid, to which we will add our 0.25 milliliters of our stock solution. That will give us a final volume of 250, and therefore we will have our 1/1000 dilution at the end. So a very common mistake for students to make is to just take your initial volume here and add it to 250 and call it good, and that would be incorrect because our final volume would not be 250. Our final volume in that case would be 250 plus 0.25, and therefore our dilution would not be 1/1000. So the only way to get this is to make sure that you're really careful and figure out your total volume at the end minus the stuff you're starting with is the amount of diluting fluid that you're going to need. Okay, so there's two examples. We will go over more examples in lab, and I might even give you a problem set to do on Canvas later for extra practice.